So I want you to look around the room you're in right now. Like, really look at the space around you. You've got the smooth curve of a coffee mug, or maybe the continuous sweep of a painted wall, even the way sunlight pours through a window in what looks like this completely unbroken beam.
Right. It all feels perfectly seamless.
Exactly. It feels, continuous.
Which makes sense because for centuries, the mathematics and physics we use to describe that reality, I mean, from Newton's calculus all the way up to Einstein's relativity, they've relied entirely on that exact observation.
Yeah.
We build our models on the foundational assumption that reality is just this smooth, continuous fabric.
But what if that assumption is fundamentally wrong?
Well, that's the big question.
Right. Like, what if the math we use to navigate reality is actually flawed because it's based on a macroscopic illusion? What if, when you zoom in far enough, reality isn't a smooth continuum at all, but like a pixelated computational grid?
It's a huge shift in perspective.
It really is.
Yeah.
And that's exactly what today's deep dive is about. We are getting into a theoretical paper detailing something called W-Topos Theory. It's described as a Gibsonian reformulation of contextual mathematics.
Yes.
And the mission of this framework is incredibly ambitious. I mean, it is attempting to unite logic, geometry, and physics into a single unified language by treating reality not as a smooth geometry, but as a discrete token-mediated computational system.
Yeah, we are essentially looking at a proposed operating system update for how we understand the entire universe.
A massive OS update.
Exactly. But to grasp why W-Topos is such a radical departure, we need to first talk about standard topos theory and, well, where it falls short.
Okay, let's unpack this, because standard topos theory is already a fairly abstract concept.
Very much so.
From what I gather in the source material, classical topos theory is like a high-level mathematical framework used for handling context. Think of it as a toolkit that allows mathematicians to do logic in different universes. Like in standard logic, something is universally true or false, right? But in topos theory, truth can depend on the specific mathematical room or context you are standing in. It's an elegant way to generalize logic.
You capture the essence of it really well. Standard topos theory is brilliant for handling those shifting contexts. However, the author of the W-Topos paper points out a fatal flaw in how it's currently applied to physics. It still wears what they call a continuum-tailored coat.
A continuum-tailored coat.
Yeah. Even when standard topos theory shifts contexts, it assumes those contexts exist within a smooth, continuous environment. It stops one layer shy of true ontology.
Meaning it stops short of describing what is physically real at the lowest possible level.
Precisely. W-Topos theory steps in and argues that discreteness isn't just a chunky approximation of a smooth line.
Right.
The smooth line does not exist, only the discrete grid exists.
And that brings us to two foundational concepts in the paper that dictate how this grid operates: the configuration space and the rendered space. And honestly, reading this part felt exactly like trying to understand a video game.
Oh, that's a good way to look at it.
Yeah. It's like standard physics is trying to explain how a game works by only measuring the glowing pixels on the television screen. They are studying the observable output, which is the rendered space or continuum.
Right?
But W-Topos theory argues that to understand the game, you have to look at the hidden game engine that's computing the code frame by frame. That hidden computational layer is the configuration space.
That's a highly valid analogy, but it raises an important question. If reality is a computation running in the background, what are the actual units doing the computing?
Right, like what are the processors?
Exactly. In W-Topos, these fundamental units are called tokens. These tokens operate on a non-uniform lattice, which is mathematically envisioned as a tetrahedral grid.
Okay.
So space and time are not an empty theatrical stage that objects simply move across. Space and time are the emergent output of local token exchanges happening on this grid.
I need to stop you there and push back on this image because it bends the brain a bit.
It does?
If space is literally just a grid of computational tokens exchanging data, what is between the tokens?
Nothing.
Nothing.
Nothing. And I don't mean a microscopic vacuum of empty space. I mean the concept of between ceases to exist.
Oh, wow.
Yeah. Distance and space are properties generated by the token exchanges. Asking what is between the tokens is like asking what is north of the North Pole.
It's just an invalid question.
Right. The geometry of space itself doesn't exist until the tokens interact to create it, and those interactions are governed by a strict step schedule denoted as T and something called the full complement rule.
Okay, let's talk about that full complement rule. If I'm understanding the source right, it means a local site on this grid only advances to its next state when it has received all the necessary tokens from its immediate neighbors.
That is the exact mechanism, and it has profound implications.
I bet.
It means there is no universal clock ticking away for the entire universe. Time only advances locally, site by site, when specific token conditions are met.
But wait, if there's no master clock and everything is just updating locally based on its neighbors, why doesn't reality fall out of sync? Like, why doesn't my left hand update slower than my right hand, like a bad video call lagging out?
Because your hands are macroscopic objects made of trillions of interlocking token dependencies.
Okay.
The full complement rule forces synchronization. Your left hand cannot physically move into a new region of rendered space until the token lattice in that specific region has received the full complement of data to permit the movement.
So it physically can't glitch ahead.
Right. And that lag you are picturing actually does happen, but we experience it at the macroscopic level as the universal speed limit.
Wait, the speed of light.
Yes, the speed of light. The speed of light is simply the maximum rate at which the token grid can process and pass full complements of information from one local site to the next.
That completely reframes relativity.
Doesn't it?
It's literally an engineering constraint of the grid. But if reality is generated step by step on a discrete, pixelated lattice, then the basic tools we use to measure it have to be fundamentally broken.
Absolutely.
Because the calculus we all learned in school relies on finding infinitely small continuous limits. That can't work if space has a minimum pixelated size.
Calculus absolutely breaks down at this layer. You cannot slice a continuous curve infinitely thin if the curve is made of indivisible discrete steps.
So what do?
W-Topos introduces discrete calculus. In this native analytic layer, derivatives and integrals are no longer based on smooth, infinite limits. They become token-weighted.
Meaning the math is forced to count the actual discrete computational steps.
Exactly.
The derivative isn't measuring a rate of change over a smooth curve anymore. It's measuring the literal jump from one token state to the next, divided by the step schedule.
Furthermore, it builds scale-sensitive oscillatory corrections directly into the mathematics. It mathematically respects the chunkiness of the universe, if you will.
The chunkiness, I love that.
Yeah. But the most profound shift in W-Topos isn't just about rewriting calculus. It is about how this discrete grid fundamentally alters the definition of truth.
Here's where it gets really interesting.
It does.
Because in standard logic, truth is a binary concept. A statement is a 1 or a 0, true or false. It's a philosophical absolute. But in W-Topos, truth becomes something called contextual realizability. Truth is no longer an abstract idea floating in the ether. It becomes a strict engineering constraint.
Yes. And to handle this mathematically, the framework introduces the W sub-object classifier.
Okay, what does that do?
Well, in a classical mathematical universe, a classifier simply sorts propositions into true or false buckets.
Right.
The W sub-object classifier, however, grades truth based on whether a proposition can actually be physically instantiated within the token grid.
So it checks the hardware.
Exactly.
Yeah.
It provides 4 distinct levels of truth: admissible, inadmissible, underdetermined, and null.
I struggled to wrap my head around this until I thought about it in terms of computer hardware.
Oh, let's hear it.
So imagine asking a laptop with just 2 gigabytes of RAM to run a massively complex 3D simulation of an entire galaxy.
It would crash immediately.
Exactly. The program you were trying to run isn't conceptually false, like the code is real, but it's computationally null.
Right.
It requires more resources and a different architecture than physically exists in that specific hardware system. W-Topos is saying reality works the exact same way.
It is.
If a physical state cannot be sensibly built using the local token rules, it isn't just unlikely, it is mathematically outside the domain of realizable structure. It's null.
And if we connect this to the bigger picture, this concept of contextual realizability completely detonates our standard understanding of quantum mechanics.
Really? How so?
The paper points directly at the famous double-slit experiment. Standard quantum physics tells us that a particle, like an electron, exists as a wave of probability, a mathematical smear of potential locations, until someone observes it.
Right. Schrodinger's cat kind of stuff.
Exactly. But the author of the W-Topos paper openly dismisses this as wave function mysticism.
Wave function mysticism. That is such a good phrase.
It's very pointed.
Because it calls out the fact that physicists have basically accepted magic as an explanation just because the continuous math couldn't provide a real mechanism.
Right. W-Topos argues there is no magical probability cloud. What we are observing in the double-slit experiment is deterministic trajectory bifurcation.
Okay, deterministic trajectory bifurcation.
Governed by token-mediated local curvature.
I'm going to need you to slow down and explain the actual mechanism there, because that sounds like more mysticism if we don't know how it actually works.
Fair enough.
If it isn't a wave of probability, what is physically happening to the electron as it approaches the two slits?
Think of the electron not as a solid pebble, but as a specific structural pattern of tokens moving through the grid.
Okay.
As this token pattern approaches the slits, it is constantly exchanging data with the lattice ahead of it, checking the W sub-object classifier to see which future states are legally admissible.
It's checking its surroundings.
Right. And because the physical slits alter the lattice geometry, trying to push the electron pattern straight through certain areas of the grid suddenly requires token updates that violate the local rules.
So the math doesn't work out.
Exactly. Those forward paths return a null truth value.
So the electron isn't choosing to be a wave, it's just hitting computational dead ends.
Precisely. The grid evaluates whether the physical state is legally realizable. When the straight path becomes computationally null, the token pattern is forced to bifurcate, to split or divert its trajectory along the only admissible lattice paths that remain.
Wow.
So the interference pattern we see on the back wall isn't a collapsed probability waves, it is a map of the legally surviving token trajectories.
That makes so much more sense.
W-Topos replaces continuous wave ontology with discrete, lawful token tracking. In this framework, truth simply means stable realizability under lawful refinement.
Okay, so truth is just local token computation. But this brings up a massive glaring issue for me.
Let's hear it.
If reality is just quadrillions of tiny computational pixels, updating solely based on the rules of their immediate neighbors, how does the universe not shatter? Like, if everything is hyperlocal, how do we get a unified, coherent, macroscopic universe that we can actually walk around in? Why doesn't the grid just fracture into a trillion disconnected, isolated sub-realities?
You've identified the core hurdle of discrete physics, and the paper's solution is arguably its boldest claim.
Okay.
It relies on a mathematical concept called sheaf gluing, but W-Topos gives it a deeply physical mechanism.
Let's break down sheaf gluing, because the terminology sounds like a scrapbooking technique.
I know it does. In standard topology, a sheaf is a tool for systematically tracking locally defined data attached to the open sets of a space. It's a way to ensure local data is consistent.
Right.
But in W-Topos, a W-sheaf is elevated to an active law of emergence. It is the strict mathematical rule ensuring that locally compatible token states uniquely assemble into one global, coherent rendered state.
Let me see if I have this mechanism right.
Go for it.
Imagine building a massive, intricate mosaic on the floor of a cathedral. But you don't have a blueprint of the final picture, and you aren't allowed to look at the whole floor.
Okay.
You're only given a pile of tiles and a rigorous set of local rules. For instance, a blue tile can only touch a gold tile if there's a white tile directly above it. If you and 1,000 other workers just blindly, obsessively follow those local rules tile by tile, the global image of a saint or a dragon has to emerge. The global picture is guaranteed by the local constraints.
The mosaic analogy holds up perfectly. The paper states explicitly, emergence is sheaf gluing under W-admissible covers.
Wow.
What appears globally in our rendered space, the observable universe we live in, is strictly and exclusively what can be glued lawfully from local token sections in the hidden configuration space.
So does this imply that the macro universe, like the galaxies, the planets, the apples falling from trees, doesn't possess any independent reality?
It does imply that.
Is the entire macroscopic world literally just a side effect of local tile rules?
The framework insists on it. Orbital stability, relativistic time dilation, the curvature of gravity. These are not sweeping cosmic forces applied from the top down by some mathematical dictator.
Right.
They are local to global assembly phenomena. Gravity isn't a giant invisible hand pulling planets toward a star. Gravity is the necessary emergent geometric shape of quadrillions of local tokens relentlessly executing their full complement rules.
That is mind-blowing.
It detonates the old assumption that topos theory is merely generalized set theory. W-Topos becomes the actual grammar of how a world physically instantiates.
And this brings us back to that word from the very beginning, Gibsonian.
Yes.
The paper calls this a Gibsonian reformulation. And in psychology, J.J. Gibson pioneered the idea of affordances, the idea that an object isn't defined by its abstract properties, but by how we interact with it.
Right. The environment matters.
Yeah, like a chair isn't just a collection of wood. It is something that affords sitting. The W-Topos paper takes this concept and applies it to quantum physics through something called the physical Yoneda lemma.
The Yoneda lemma is a famous result in category theory, but when mapped to this discrete physics, it tells us that a local state is never a dead pebble.
Meaning?
An object, whether it's an electron or a coffee mug, is not a static, isolated entity. It is entirely defined by its lawful token relations to the surrounding context network.
So a thing is nothing more than its relationships.
Exactly.
An object is literally just the sum total of how it interacts with its environment, what it affords the tokens around it. It is known solely by all the lawful ways it can be embedded, restricted, and tested by neighboring patches of the grid.
Which means physics is fundamentally ecological. A particle doesn't have intrinsic properties hiding inside it. Its properties are its interaction rules with the lattice.
That is philosophically beautiful.
It really is.
But practically, it sounds like a nightmare for scientists.
Oh, sure.
Because if everything starts at this microscopic, token-level mosaic, how do scientists actually study anything big? Like, a chemist studying a beaker of acid doesn't want to calculate the individual token updates of a trillion atoms.
No, they'd be computing a single chemical reaction for 1,000,000 years.
Right, so if the universe is built from the bottom up, how do we zoom out to study the top?
That is where the mathematics of W-Topos flexes its true power. It solves the scaling problem using a mechanism called geometric morphisms.
Let's break that down, because a morphism usually implies some kind of transformation.
In category theory, a geometric morphism is a lawful mapping between two different toposiso, two different logical universes.
Okay.
In W-Topos, these morphisms provide a principled, mathematically rigorous way to translate a fine-grained token topos into a coarse observational topos.
So what does this all mean for the chemist? Walk me through how a morphism actually gets us from tokens to a beaker of acid.
Consider a single droplet of water. At the configuration layer, it is an incomprehensible swarm of discrete tokens executing step schedules.
Pure chaos to look at.
Exactly. If you try to map that directly to human observation, it's noise. But a geometric morphism acts as a mathematical translation dictionary.
Wow.
It takes the rigid local token laws and translates them into the next logical scale up subatomic particles. Then another morphism maps the particle rules into atomic rules, the H2O molecule. Then another morphism maps the molecular rules into fluid dynamics.
And the crucial part is that nothing is lost in translation.
Right.
Usually when scientists talk about emergence, like how wetness emerges from water molecules, it feels like a bit of a philosophical handwave. Like, step 1, atoms. Step 2, magic happens. Step 3, a wet puddle of water.
What's fascinating here is that W-Topos replaces that magic with rigorous syntax.
Yeah.
These geometric morphisms must strictly preserve token law.
Wow.
When you zoom out from the microscopic token level to the macroscopic chemistry level, you aren't just blurring the image and guessing at the fluid dynamics.
The math proves it.
Yes. The morphism ensures that the macroscopic rules of fluid dynamics are a mathematically perfect, unavoidable consequence of the underlying token constraints. The wetness of water is mathematically derived from the configuration space.
So it provides an unbroken bridge. We can move between completely different domains of reality, from quantum physics to fluid dynamics to astrophysics, without ever having to fall back on the illusion of a smooth continuum.
Exactly.
The entire universe holds together from the bottom up, mathematically verified at every scale.
It successfully unites category theory, logic, and discrete physics. Under W-Topos, they stop being separate, isolated kingdoms of science. They become interconnected provinces of the exact same computational empire.
Okay, let's bring this all together, because this has been a massive paradigm shift.
It really has.
The old mathematics, the classical topos theory, gave mathematicians a way to say that sets vary over contexts. But this new W-Topos framework declares something infinitely more tangible. It says that worlds vary over token law.
Classical math provided a beautiful logic container, but it was empty. It was waiting for a physical reality to be poured into it. W-Topos theory argues that the container and the reality are the exact same thing. The discrete token calculations are the geometry. The contextual realizability is the truth. Emergence is the sheaf gluing. It takes contextual mathematics and makes it computationally physical.
It is an incredible way to view reality.
Yeah.
But before we wrap up this deep dive, it leaves me with one highly provocative thought that I want you, the listener, to mull over. Yeah. We've spent this time exploring a universe that is fundamentally deterministic at the lowest level, right? A reality where every movement, every geometric shape, and every force is just the strict, unavoidable execution of local token rules and step schedules.
Yes, that's the core of sheaf gluing.
But if our reality is constantly being assembled and glued together from local discrete token calculations, what happens when two local patches of reality are forced to compute conflicting truths?
Oh, wow.
Right? Do they just become null? Like, is it possible for the universe's rendering engine to actually experience a glitch where the gluing law fails?
That is a wild thought.
And if so, what would that glitch look like to us in rendered space? Think about that next time you look around your perfectly smooth room. Until next time, keep diving deep.